researchers, welcome to video number 9. In this video, we are going with our discussion on the CMV, common method variance or common method biasness. In the prior video number 8, and I advise you, if you haven't watched that video, to go back to video number 8, we have discussed CMV and we have discussed some preventive remedies or measures that we can take to deal with or to take a preventive action before CMV happens. However, in this video, we are addressing CMV in some occasions after it happens. However, we are also bringing in some advice on what to do even before you collect your data from a statistical perspective. So CMV can be a major problem in your research, in your PhD study. It may require you, if you don't pay attention, to redo your data collection and recollect your data, or end up with findings or conclusions that may not be empirically correct, and you may end up making wrong or erroneous conclusions, and you may end up as well kind of like questioning theories that are founded correctly based on empirical data that is inflated, that suffers from common method biasness. So it is crucially important. It is crucially important to make sure that your data has no or suffers from no or at least a bit of common method biasness. In this video, we're shedding further light on common method biasness, and we are addressing 4 ways to detect and possibly deal with common method biasness. Okay, the first method is Harman single factor test, and the second method is the unmeasured market variable or the partial correlation matrix, and the third method is the measured market variable, and this is through SDS, the social desirability scale questions that you can add to your surveys just to test for or detect CMV. Further, there is one method that has been linked with smartpls, our software of this channel, which is the checking for the VIF factors, specifically the inner VIF factors. Alright, so these are statistical ways and remedies. There are many others. However, these are probably the most common in the literature and the most researched. However, there are probably some other methods of higher statistical standards and probably more complex to conduct and analyze. However, for a PhD student, these methods might be sufficient. Okay? Because dealing really with CMV is essential. In your PhD research or even in your publications, because currently high standards universities or universities with hard yardsticks may require from you an interpretation or at least a satisfactory interpretation of CMV in your research. Even publications do say. Alright, in this video, we're gonna now move to demonstration, and we are going to demonstrate using SPSS, using our data in Excel, and using smartpls in order to show you how to go along treating or dealing with CMV in our PhD. Stay tuned and let's move to demonstration. Thank you. My fellow students, let's continue with video number 9 in our smartpls YouTube channel. We are focusing on CMV statistical remedies. Let's move on. Okay, in this video, we are focusing on the statistical remedies of CMV. All right. So, as I mentioned before, CMV can measure source of potential measurement errors. It may offer new theoretical data and empirical findings that are not supported by empirical analysis or correct empirical analysis. In addition, it may lead you to question theories that have been already empirically and correctly founded. All right. So it is very important to understand the CMV problem in your data. One method that we use to check for CMV is the Harman single factor method or single factor test. It may be accepted in many universities and many publications. However, some universities, some publications may not prefer the Harman single factor test. What do we do in this? We find the unrotated first factor that should be less than 50%. And how we do this? We do it in SPSS, and now we're going to do it in SPSS. And we have several criteria. Usually this factor has to be less than 50%. If it is less than 50%, then we have no CMV, or CMV is not an issue. This is according to Batskov and Organ. However, we got also another criteria or a threshold, which is 40%, and this is according to Bibin 2016. So a single latent factor less than 50% means CMV is not an issue in the structural equation model. All right, let's move there and see what we can do there. All right, we go to smartpls here, SPSS here. And in SPSS, we have our data studying the factors influencing online banking queues. All right, so we had already our data in. Okay, I don't want you to look for those SDC, the social desirability scale. We'll come to those later on. I added those today because we're gonna come to them once we address the measured marker variable. Okay, so we have our data here. Okay, how do we find the Harmons, or how do we run the Harman single factor test? Okay, it's very simple. We go to analyze, and then dimension reduction, and then factor. Okay, let me reset those. Okay, and then we pick up all of our variables, and then shift, and we go up to the last one, which is TLS, the trust 5. We don't take those STS because they are not a part of the original data. I just added those for the sake of CMV analysis. Okay, and we take them in here, all right? So descriptive, we leave it as is, and then the extraction, we go into the principal access factoring, okay? We pick up principal access factoring for the the factor analysis, the extraction. Okay, based on eigenvalue, we fix the number of factors, we force it into 1. Okay, we force our fixed number of factors into 1, and then we click on continue. We go to the rotation, none. We don't choose any rotation with the single factor test. We leave it as none. All right, scores, we have to save our scores. Save, no, we don't need to. Okay, just continue, and we click OK. All right, and here we go. We get the results in here. Okay, and this is our result. Okay, we have a data here showing me view, and all right, I'll try to zoom further with that. Okay, now, all right, so as we notice here, we have a factor, a threshold or level of 27.314%. And if we go to our PowerPoint slides, so it is less than 40% and it's as well less than 50%. Okay, so 27%, 0.13%. This indicates that we do not have a problem with our data, with a CMV problem here. Okay, we do not have a CMV problem here. All right, this is for the Harmon single factor, and this is the way we run the Harmon single factor. I can simply repeat this. I simply go analyze and then dimension reduction. Okay, analyze, dimension reduction, and I'm just trying to, okay, so analyze and then dimension reduction, factor, and then reset those. We simply take all our variables and we run it. Okay, we get the results here as 27.13%, and this meets the threshold as suggested by Batskov and Oregon 1986, or even by Babin. And you can simply cite those references and claim that you have no CMV problem in the data. Okay, so this is one method. Another method here, okay, from the current slide, okay, is the partial correlation method. A partial correlation, or the EFA, exploratory factor analysis. Here we go to our data. Okay, what we have to do is that we have to save factor score and point it on the dependent variable and then compare the R square, okay, of the dependent variable or the beta for each independent variable in our structural equation model. Okay, this same method is also called the unmeasured marker variable, or the measured latent method construct, ULMC. All right. I have to warn you as well, EFI method may not work most of the time, as if a CMV is inherited. It may show again in the data. All right, let's go to here. Let's go to the SPSS and okay, and see how we can deal or get this method running. Okay, as well, it's simple. What we have to do is we have to go to analyze and then dimension reduction and then factor. Okay, I already reset my factors simply the same way as I followed before. I go into shift, click here, and then go shift and pick up all my variables, all of them except the SDS. All right, I don't need the SDS. All right, and then for descriptive, same, leave it the same. For extraction, I do as well principal axis factoring the same way, and then unrotated factor correlation. I don't have to force fixed number of factors into one. I don't fix it into one because we will have several factors, the same as the number of the constructs that we have in this study. And in this study, we have 6 constructs. We end up having 6 factors in the analysis. Okay, so we go continue rotation. In the rotation here, we have to pick up varimax rotation. Varimax rotation. Here we have to pick up varimax rotation and then continue. Scores. I have to save the scores. Save the score, save as variables. Okay, save as variables and then continue. and then options. Okay, I don't need to do anything with the options. Continue, and then okay. Okay, as you notice here, okay, we'll go back to our data set here, okay, to our data set. And as you notice, in our data set here, we find, okay, we find in our data set, we find 1, 2, 3, 4, 5, 6 factors, all right? So 1, 2, 3, 4, 5, 6 factors. I don't need to worry about all these factors 1 to 5. Simply, I can simply remove those factors, delete those, okay? Simply can delete those factors and stay only with factor number 1, okay? And simply, I can rename this as the unmeasured marker variable. Okay, so now variable, okay, and okay, I don't have unmeasured marker. Okay, unmeasured marker. Okay, okay, simply cancel. Okay, I have the unmeasured marker now here. What I do now is just save the data, save my data. So I have my unmeasured marker here. I simply save my data. So save data, time extended SPSS data, and then I'd say here unmeasured marker. Okay, unmeasured marker, and save. All right. So I have now a new set of data with the unmeasured marker added. Okay, what I do now is simply I go into smartpls, okay, I go into smartpls and I have to import the new set of data. So I'll go here and simply import a data file. Okay, video number, this is the unmeasured marker. This is the new set of data, okay? So I simply, this is the new set of data. I import this set of data in, okay? Unmeasured marker, I leave it the same. Okay, and as you notice here, I have here a new set of data. Let me activate this, select active data file. So I have this activated, I don't have the other one activated. All right, so very simple here. What we do here is go to the model that we have. Let me go to the presentation here, partial. This is the unmeasured. Okay, so go simply to the presentation and to the model that we have. Okay, and here what we have to do is that I have to point out this new factor, the unmeasured factor, into our dependent variable in this case. Okay, what we have to do is simply go and then, okay, this is, let me rename this the unmeasured market, okay, marker variable. Okay, I rename it this. Okay, and simply let me connect it to our dependent variable. So I pointed out to our dependent variable, and I see I have it now red. What we have to do is that take the indicators of this variable into this one. All right, and then okay, and then I have this. You can just simply make it look a bit better here. Okay. All right, and then what we have to do here, so I pointed the unmeasured marker variable to our dependent variable. Okay, and then what we do is that, okay, but before you doing this, let me run first, because we have, as I mentioned here, we have to compare our R square of the dependent variable or beta for each independent variable before before adding the unmeasured marker and after adding the unmeasured marker. Okay, let's first run our algorithms here, okay? PLS algorithms, your current is not, because this one is, let me just delete this one, and this is usefulness number 1, okay? This is the one, okay? I simply add it here, okay? Okay, let me now calculate PLS algorithms, okay, and then start my calculation, all right? And then I go here to this one, and as you notice here, I have my R square. This is my R square. On the dependent variable, my R square is 0.106. What I do here, let me go into a Word document just to document the difference. Let me go into a Word document here. Okay. Okay. Or simply I prepared already, let me, okay, cancel. Let me remove this and let me remove this. But what we can do, okay, so view, zoom, let me just increase the zoom here, make it 150. All right, here, let me go back to our model and simply copy what I got. Export as an image to file. No. Let me export this as an image to clipboard and simply paste it right in here, okay? So this is our model, and these are our R values, okay? These are our R values. As you notice, these are our R square values for the dependent variable. So now let's see, all right? Let's see what happens after we add the unmeasured market variable. Okay, as we notice here, let's go to our model again. This is our model, and simply, so we have now, this is the model, and we got the data here. Okay, we have the, without the marker variable, we got 0.106 for the R square. Okay, let's add it now and see what happens. Okay, so simply add, okay, and connect. All right, let's connect it. Point it out to the variable, and then let's get its variable, its indicators, put it in here, and then let's let me remove. Let me just fix this a bit, make it look better, and then what I have to do here, just rename it, okay? Rename this as the unmeasured and measured marker variable, okay? And simply I have the indicators in. What I can do here is simply rerun, okay? Calculate PLS and then rerun the algorithms, okay? And see what the change would be then. All right, okay. Here we notice that I wouldn't worry about the indicator here. Here we notice that the R square has changed. Okay, it is now, let me as well copy this. I can simply export, copy this, and paste it here. Okay. Now the R square is 0.357. Okay, the R square with the marker variable or the unmeasured marker variable, it is the 0.357. This is a bit high here. It's not less than 10% the difference actually, and this may indicate here a CMV issue. Okay, so using this method, the unmeasured marker variable, I have noticed that my data may have some CMV problem. Okay, however, let's just remove this and move next to our next method, which is the measured market variable or the social desirability scale. It is very important first to introduce you to the social desirability scale. What is social desirability scale? Social desirability actually has started with Marlowe and Crown uh, uh, decades ago, and it is actually used. Let me just go to one article here that may discuss it. See, development of reliable, valid, and valid short forms of the Marlowe-Crohn social desirability scale. So overall, a social desirability scale is usually has started as 33 items, 33 questions that are used in order to check how desirable or how positive may the respondents be with the questionnaire, or they may alter their responses or just change their responses under the social desirability. So, for instance, like if society desires this way, then they may end up answering as the society desires rather than as they personally desire. So this is a social desirability scale, and usually it is added. You may take few items, maybe 5, maybe 7, maybe 8, maybe 4 items, and you just add them to your questionnaire. They are not relevant indicators. They are not relevant questions to your questionnaire. However, they can play an important role in detecting CMV. All right, I'll just show you here some questions that may come into this scale. For instance, here before voting, I thoroughly investigate the qualifications of all candidates. I never hesitate to go out of my way to help someone in trouble. These are some indicators on the social desirability scale. So in our study here, we simply add a few. I added 5 indicators to my questionnaire, as you notice that, and I collected the data on those. So if we go to SPSS, you can find here 1, 2, 3, 4, and 5 questions that I added to my questionnaire and collected the data for in order to do what? In order to test for CMV. And it is really important. And here, researchers and activists in the CMV studies require or recommend collecting the CSDS results or social desirability scale results. And this is what we call here the measured market variable. Okay, so collect a marker variable using the Fisher and Fick SDS. Using the same correlation method, we have to notice that any correlation greater than 30% between your marker variable and the principal constructs should indicate a problem. Okay? And the principal construct should indicate a problem. A possible solution may not be easy. In case we face a CMV here, you may require to collect your whole data. SDS usually are totally unrelated, as I mentioned. So we are studying the factors influencing online banking use. But SDS questions are totally different. We simply just plug them in order to assess our CMV. All right, let's see what we can do now. Let's go to the to the data here, I have the SDS already, and it's already in the new set of data. Let's go to our, it's already in this set of data, okay? So simply I would remove this, okay? Remove this and create a new variable here. I'll call it the measured marker, okay? This is the measured, not the unmeasured, measured marker, okay? I can simply add STS if I wish, okay? And I rename it this, and I would just connect it into the dependent variable as I did. And these are the indicators for this variable. STS1, 2, 3, so 5 indicators. I simply plot them in here, okay? And do what now? Rerun the analysis. Okay, so calculate PLS algorithms, all right? And then start calculations, okay? All right, and let's see simply what happens. Okay, so if we notice the same way, what we have to do is that we have to compare our R square. This is our R square. Here it is 0.11. Simply you can just copy the whole or simply take this. It is 0.11. So this is with the marker variable, okay, and this is comparing R square, using here, using the SDS market variable, measured marker, okay, measured marker variable, okay. This is here, okay, and okay, simply here using the unmeasured and measured market, or marker variable, and the partial correlation method, okay. Start, all right, okay. So simply it is 0.11 as the results indicate here. So this is another finding that allows us to claim that we have no CMV problem in our data set or in our results. Okay. So you can simply cite here. We have the Fisher and Fick. This is for the social desirability, and you simply have your citations, and Chin 2013, and simply claim that you have no CMV in your data. Okay, one thing I don't want to forget, if we go back to our model, this is one way. Another way, as I mentioned here in the social desirability scale, using the same correlation, it has to be any correlation greater than 30% between the market variable and the principal construct, we indicate a problem. So this is a 6%. This is the path efficient, the correlations. It has to be lower than 30%, and this is 6.8%. So this should not indicate a problem. So, and as I mentioned, we have two ways. We have the comparing the R square or comparing our beta, as I mentioned, square dependent, or beta for each independent variable, and should not be much different. In case here we want to work on the beta, we have then to point out the measured marker variable to other to our independent constructs, and check for the of course, get the results now for the beta, and then after we add the measured marker variable again, we compare what happens, and the results for the beta have to be less than 10%. Okay? So in the measured marker method, or using the social desirability scale, we compare R square has to be less than 10% the difference before adding and after adding the measured marker. And also we can use the beta by pointing out our measured marker to our independent variables in the study, and then we have to compare the beta and see no difference that is higher than 10%. Also, we can check for the correlations, as I mentioned here, the correlations between marker variable and the principal constructs, and it should not be higher as well than 10%. It should not be higher than 30%. Okay, so what would be a possible solution if we have a CMV? No, we have to collect more data. There might not be a possible solution. We have to collect more data here. Okay, and let me go back to here is my model here. Okay, and then let me go back to, so questions of the social desirability simply give a difference, change the consistency, give a different topic, and check for the connection between the respondents and how socially desirable they may be. And this would give an indication on the CMV. A few questions, as I mentioned, will do. Comparing R square is much easier for you than going into beta. And the difference should not be higher than 10%. Any higher difference would indicate a problem. We do another table for beta comparison by, okay, so if we go for beta, then instead of using this table, or simply we add another table that would compare with and without the marker variable using beta coefficients. Okay. Okay. Beta coefficient. And so one method that's left, okay, and this has to do with a smartpls itself. This is checking for the inner VIF factors. Okay, I have recently read an article by Koch 2015. It actually uses smartpls to check for VIF factors. But what we got to do here in smartpls, okay, we have to go back to smartpls here. What we have to do now, we're done with the measured market variable. Let's remove this. What we have to do is that we have to point out all of our constructs that we have to the independent variables. So let me remove this. Okay, and this has to be, this also to be removed. Okay, I can simply hide all these, hide all indicators, simply hiding all these, and simply this one, all right, select, and let me just also, all right, okay, zoom in more, zoom in more. All right, so simply I select this and just to point it out to here. So this is pointed out, this is pointed out, and this has to be removed. Let me remove this. Okay, and I still have to point this to this. Okay, and point this, okay, point this, okay, to this. All right. So in this way, as you noticed, I have pointed all my constructs to the dependent variable, which is the actual system use. What I do here is simply go calculate and then choose consistent PLS algorithm. Okay, not the regular, the consistent PLS algorithm here. Okay, connect all LVs, okay, for initial calculations, and keep everything as the same, and simply run the calculations. Okay, what I have to do here, okay, and from this slide, let me make it bigger. Okay, here we have to check for the inner VIF. How do we check for that? For the inner VIF, I go into here, all right? Collinearity statistics VIF, and then I go into inner VIF. Okay, as long as we have an inner VIF lower than 3.3, then we can conclude that we have an OCMV problem. And as you notice, as long as it's green, then we have an OCMV problem. We can simply state that, and what we do is simply cite COC 2015. All right? So, anything, any inner VIF factors less than 5, it means a minor CMV. We have CMV, but a minor. Between 5 and 10, it's a moderate CMV. However, higher than 10, it's a very major CMV problem. Okay, so this is the fourth way addressing CMV using statistical method. So we used Harman single factor, and we used the partial correlation method, and we used the measured market variable, the STS, and now we use the inner VIF factors using smartpls. Okay, and from current slide. So in conclusion, we have to collect your measured market variable first. It is very important. Like once you want to distribute your questionnaires, it is very advisable. This is the moral here of the story. It is very advisable you collect your measured market variable first. Use simply few questions, so don't make it hard on you. Use simply few STS questions. Ensure CMV is under control. It is very important for thesis study and for publications. Okay, in the prior video, we addressed the preventive procedures that you can use before collecting your data, like consistent answering, extreme answer, acquiescent responses, answer through relatively automatic process. You have to avoid all of these through preventive measures that we have discussed, and you can go back to video number 8. In the statistical ways, there are many statistical procedures. A first group would use Harman single factor and the correlation matrix procedures, as we have demonstrated in this video. However, they may not be sufficient. There is also another group of statistical remedies that would let researchers only test CMV, but also measure the partial out the bias generated by CMV, like for instance, directly measured latent factor method and the measured response style technique. There is also a third group that can be applied to test and control for CMV without having to identify and measure the sources of CMV, like correlation-based marker technique, general factor covariate technique, etc. If you have any questions, please do not hesitate to text me, and probably in coming videos we may address further statistical remedies. However, what we did in this video and the prior video number 8 would be actually sufficient. And I stress it again, the moral of the story here, you have to control your CMV. You have to know and you have to cite that your claim that you have no CMV. All right. Thank you for watching, And if you have any question, please ask me, and please stay tuned for coming video number 10. Thank you very much, and goodbye for now.